a star by you, you get to use a calculator for that problem. So this quiz will be separated, like our tests are, into calculator and no calculator. So let's get all the no calculator stuff done. You might have, I don't know if I mixed them up here or not. So we'll do all the no calculator things first. So evaluate sign 315. If you have memorized that unit circle that was in the notes, which is totally an option. I don't have it memorized. It's totally an option. But if you've done that, then you know, bingo, what the answer to this is. I haven't memorized it, so I'm going to draw a 315-degree angle. Remember, I start measuring here. I'm not going to do this every time, but just to remind you, that's our framework, right? In standard position. So if this is 315, then this is 45, and the sides are 1, 1, root 2. Bing, bing, I'm not in quadrant 1, so something's negative. In this case, it is the y. Remember, your hypotenuse or your radius, whatever you want to call this, is never negative. So the answer to the problem, the sine is opposite over hypotenuse, or y over r. So that's -1 over root 2, negative root 2 over 2. Got it? Tan pi. Where's that? Where's pi?
180.
Pi's 180. So here I am. Well, shoot, I can't really make a triangle, so I'm going to envision a whole circle here. And what would be the coordinates of that point right there? That's the 180 or the pi point.
Negative 1, 0.
Negative 1, 0. So x is -1, y is 0, r is 1. That's my setup. That's the way I created it. And I want tangent. Tangent is y over x. You guys gotta memorize that. Remember the circular definitions, you gotta know them. Tangent is y over x, which is 0 over -1 or 0. Cosine, 2 pi over 3. Now, you don't have a calculator, you don't need a calculator. You just got done telling me that pi is 180. So pi over 3 would be 60. And 2 60s is 120. So this is the cosine of 120 degrees. So that's over here. In between 90 and 180, right? What's the reference angle? That's this guy right here.
60.
60. So root 3, 1, 2, those are the sides. Bing, bing, I'm not in quadrant 1. So what's negative? The 1? X. Right? I want cosine. Cosine is adjacent over hypotenuse, or x over r. That will be -1/2. Secant -pi over 6. Well, if you need degrees, that's what? -30, because pi is 180. Pi radians is 180 degrees. So 1/6 of pi would be 1/6 of 180, which is 30. Negative now, remember negative means we go this way. So there's my 30-degree angle negative. Right, down in quadrant 4. If that's 30, this is 1, 2, root 3. Bing, 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 we're not in quadrant 1. So what's negative? The y, the 1. Secant. Secant is reciprocal of cosine.
Hypotenuse over adjacent.
So adjacent over hypotenuse, so katoa is cosine, so it would be hypotenuse over adjacent. So 2 over root 3, or 2 root 3 over 3. cotangent 195 pi over 4. Would everybody agree that's a pretty big angle? Which means if I were to draw it like that, I would be going round and around and around a few times, right? And all those extra revolutions don't matter. All I really need to be able to do is draw a triangle like this, so I don't need all those spins. So if I think of this as (48 3/4 pi, would you agree with that? Did I divide right?
Yeah.
48 3/4 pi. Tell me about 48 pi. What does that do for me? 48 pi's.
24.
Marin?
It means you're going, like you're making 24.
Exactly. Every revolution is 2 pi. So this would be 24 revolutions. Spin, 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 spin. Forget it. Don't care about it. All we care about is that extra leftover part after we take out all the spins. This is the smallest positive coterminal angle for that big guy. So 3 pi over 4. Well, pi is 180. A fourth of that is 45. And 3 45s is
135.
135. So 135 is over here, which makes my reference angle 45. So 1 root 2, bing, bing, bing. I'm still not in quadrant 1, so negative down here. Cotangent is reciprocal of tangent, TOA. So instead of opposite over adjacent, it'll be adjacent over opposite. So this one is -1. Okay, that's plenty of practice with those kind of problems, right? We good? All right, one more. Cosecant -2 pi. Where is -2 pi?
-180. -360.
And where is -360?
10.
Isn't it right here?
Yeah.
Cosecant. Okay, remember, x is 1, y is 0, r is 1. That's this point right here. Sine, the reciprocal of the cosecant, sine is y over r. So this is going to be r over y. That's going to be undefined. Can't find the cosecant of -2 pi. Good? All right. Now, moving on to something different. Find the radius. This problem screams arc length to me, because isn't 5 an arc length? And I know that arc length equals radius times radians, right? So arc is 5, radius is I don't know, and that's a radian angle. There's no degree mark on that guy. That's a radian. That's exactly what I want it to be. So what's r? 5 divided by 1.2?
Can we leave it like that?
Well, Mr. Shadio says yes. So, he's the nice teacher, I'm kind of not. So, okay, yes.
On F, if it's like at a point 10, how do you know what the radius is, or is the radius 1?
If this is the point 10 test, what would the radius of that circle have to be?
1.
Yeah. And we talked about back when we did this, that we use 1 because that's the easiest thing we could possibly use. But who remembers, I did a problem where we made it something else, and what happened? It doesn't matter, it doesn't matter. So you can use whatever radius you want, but all the other people in the world are going to use one. Okay, but you're unique. All right, number 3, find a positive and a negative, by the way, me being me, would think of this as 50 over 12, and then I would make it 25 over 6, because I don't like to mix my fractions and decimals. But Mr. Shadio says it's okay in AP land, so it's okay with us, I guess. All right, number 3, find a positive and a negative coterminal angle for 117. You can't miss this. What's a positive one?
477.
117 plus 360, which is what? 477, did I add that right? And then what would a negative one be? 117 minus 360? Negative 243. There we go, easy. What about negative pi over 7?
Plus or minus 2.
Negative pi over 7 plus 2 pi, which is 14 sevenths, so 13 sevenths pi. You okay with that? And then the negative one will be negative pi over 7 minus 2 pi, which will be negative 15 sevenths. The common denominator, 2 pi is 14 sevenths. So we add 14 sevenths and subtract 14 sevenths. All right, let's skip 4 for a second, because it needs a calculator. Let's do 5. What is the degree measure of the angle described by south-southeast? So think of a compass. Here's south, here's east. This is southeast, and then this would be south-southeast. Would everybody agree with that? It's on the south side of the southeast line. Now, it's a compass, it's a direction. So this is where we start. This is the only time we start there, but we start there. So we need to know how big this purple angle is. The big split, the main split is 45, right? Then these little subdivisions are 22 and a half. So you can do this a couple different ways. Straight down would be 180. But we didn't go this last part, so 180 minus 22.5. Or you could do 90, 45, and 22.5 and add all those up. So what is that, 157.5 would be the navigational angle associated with south-southeast. Alright, and then finally the last no calculator problem. This is the lunch period, so I gotta keep track of that. The last no calculator problem is 6. It says, given cosine equals negative 2/3 and tangent is positive, find all the rest of them. So we need sine, tangent, secant, cosecant, cotangent. Well, the good news is, one of those we already know. I mean, they gave me cosine, but then they also gave me secant, because secant is the reciprocal of the cosine. This is why I think we need to recap. There's a lot. There is a lot to know. It's easy, but there's tons of it. Okay. All right. I gotta find all the rest of them. I think I need a picture. But I gotta figure out where to draw my triangle. I don't know my angle, but I don't need it. I just need to know which quadrant I'm in. I know the cosine is negative. So cosine is associated with which letter, X, Y, or R? Well, X and R, but R is always positive. So X is really the one that tells me about cosine. So if cosine is negative, then X has to be negative, which puts me either here or here. Those are my two options. Now it says I need the tangent to be positive. So I want you to think about this for a second. If I'm in this quadrant, this would be positive and this would be negative, right? If I did the tangent, opposite over adjacent, y over x, would that be positive? No. What about down here? Down here, this and this would both be negative. If I did the tangent, would that be positive? So that tells me where I'm at. I'm in quadrant 3. So I have a picture in quadrant 3, and I know that the cosine is negative 2/3. Now I noticed in your homework, some of you goofballs love the Pythagorean theorem, and that's okay. But you gotta use it correctly. Do you always add these two up? No. Remember, the legs have to add up to the hypotenuse. So this is gonna be 4 plus y squared equals 9, right? So this is not root 13. This is negative root 5. Why is it negative? Because it's in the third quadrant. Right? Now, here we go. Now I can fill it in. So what's the sign? The sign is y over r. So negative root 5 over 3. This is y, this is x, this is r. Or adjacent, opposite, hypotenuse, however you're thinking about it. If the sign is negative root 5 over 3, then the cosecant is negative 3 over root 5. What's my tangent?
Negative root 5 over negative.
Actually, root 5 over 2, because the negatives will cancel. So your cotangent is 2 over root 5. Anybody have a question about that? Okay, so now we're gonna get our calculators out. And we have to go back and do problem 4. We'll do the rest of the calculator problems. Alright, so we've actually done ones like 4 before. My starting point is 251 revolutions per minute. Would everybody agree with that? That's my starting point. And my ending point is going to be miles per hour. That's what I want to end up with. So, this happens all the time. We either have revolutions or we want revolutions. Either way, we make the transition by remembering that one revolution is a circumference. So, one revolution is a circumference, which for this tire would be 38 pi inches. So now these are gone. Don't worry about revolutions. Now I got distances. I have inches. I need miles. Okay. So 1 foot is 12 inches. Are you with me? And 1 mile is 5,280 feet. So now I have miles. I need hours, I have minutes. So 60 minutes is 1 hour. And are we done? So 251 times 38 pi times 60. Divided by 12. And 528. I got 28.38 miles per hour. What about you?
That's what I got.
That's perfect.
So this score,
Oh, we're not done. Don't pack up. We still have no we have calculator problems on that. What, Sue?
this RPM, that always is gonna refer to revs per minute,
Mm-hmm.
never a mile.
Yeah.
Okay.
Yeah. All right, number 7, Parker is standing 310 feet from the base of a tree that is 53 feet tall. Does that picture make sense to you? Remember, you can always assume the tree is straight up. Find his angle of elevation. This is the angle of elevation. The angle of elevation is always measured with the horizontal. Okay, so is the angle of depression, by the way, they're the same. All right, so how do I find it? It's a right triangle, I'm thinking SOHCAHTOA. What function, sine, cosine, or tangent?
Tangent.
Tangent, why tangent? Yeah, I don't know anything about the hypotenuse, I have opposite and adjacent. So tan theta equals 53 over 310. Now, I didn't tell you in the problem whether you're in degrees or radians, so I would have to accept both answers. If I'm in degrees, I get, whoops, if I'm in degrees, I get
It looks like this one put in the back.
if I'm in degrees, I get 9.70 degrees. If I'm in radians,
I got it in radians.
change your node. If I'm in radians, I get 0.17. I will try to tell you, but if I forget, either one of those would be okay, because you're giving an angle measure, and you can do that in more than one way. Marin?
Angle of elevation and angle of depression, are those considered terms?
What?
Angle of elevation and angle of depression, are those terms that we need to, fitness?
Yes, but you did that in geometry class.
But I know, I was just trying to remember, elevation is like going up and then depression is looking down.
Yes. But look, if there's a bird at the top of this tree looking down at the sky, this would be his angle of depression. And that is exactly the same as the angle of elevation because they are alternate interior angles.
Okay.
So they are the same angle.
Did we write 0.17 like radians at the end?
No, if there's no unit, it means radius. Yep. All right, wait, guys, wait, we gotta get through this, come on. Number 8, at least we have to get through it. All right, so solve this triangle. Angle C is 90, angle H is 58, don't know what S is, and side H is 14. Remember, that's how we label our triangles. Where you put the CH and S, I mean, how you set your triangle up isn't important, but C is the 90, H is the 58, and across from the 58 is the 14. And your job is to find everything else. Okay? So what will everything else be? I mean, oh, angle S is a no-brainer. What's angle S? 32 degrees, yeah, we got that, okay. Then I need side S and side C. So there's lots of ways to it. What's your thought? Could I say tan 32 equals equals S over 14. Would that be one thing to say? Not the only thing by any means, but would that be something to say? All right, so then S is going to be, now this is a degree, so please do make sure you're in degrees. These are degrees. So 14, 10, and 32. I got 8.75. Did you? If we add labels, like when we do word problems later on in chapter 5, we're gonna have, this will be like 14 miles, so this would be 8.75 miles, right? And then side C, could I do something similar for side C? Yep, I could say maybe what? Sine 58 equals 14 over C, is that a true statement? Opposite over hypotenuse. So C sine 58 equals 14, and 14 over sine 58 is side C. $16.51. Now, there are lots of ways that you could have found side S, and lots of ways you could have found side C. Whatever you do, avoid round off. There's no need to use rounded off answers. So if you want to do the Pythagorean theorem to find side C, you can, but use the decimal that's in your calculator. Don't use 8.75. You see what I'm saying? Doesn't matter, there's lots of things you can do, but never use round up if you don't have to. All right, so we are gonna be back in our seats at, what will it be? 12, oh, let's just say 12:10. We're back in your seat at 12:10. That's about right. Don't need it.
I do, I fix a zero, I'll punch it.